First one, a signal x of t, a signal x of t equal to sync pulse. Okay, a signal x of t equal to sync of 150 pi t is sampled at a rate of 100 hertz, at a rate of 100 hertz, 200 hertz, 300 hertz. Okay, for each case explain we can recover the signal x of t, from the sampled signal, Okay, so this is a problem. Today problems are related with sync pulse. Okay, sine function, cos functions already with problem we discussed, and today problem related with sync pulse. X of t equal to sync of 150 pi t. Just 1 minute, I'll close the door. Okay, right. So, what is the signal given? X of t equal to sync of 150 pi t. Okay, so the sampling theorem we discussed using frequency domain analysis. So we have taken the CTFT of x of t and plot it in the frequency domain. Then Fs must be greater than or equal to 2 times of Fm. Now x of t equal to sync pulse of 150 pi t. If we draw the spectrum, for this particular signal, sync pulse, CTFT of sync pulse will give rectangular pulse. Please remember, CTFT of sync pulse will give rectangular pulse. Omega versus x of j omega. Right side 150 pi, left side minus 150 pi. The magnitude is 1 divided by 150. Okay, please remember, CTFT of sync pulse. CTFT of sync pulse is rectangular pulse. 150 pi. So now here 2 pi fm, that is omega f. Omega m equal to 150 pi. Omega m equal to 150 pi. Okay, or 2 pi fm. 2 pi fm equal to 150 pi. Pi will be cancelled. Fm equal to 75 hertz. Fm equal to 75 hertz. So what is an Nyquist rate? Formula for Nyquist rate. Fs must be greater than or equal to 2 times of Fm. Therefore, 2 times of 75. 150 hertz. As per the sampling theorem or Nyquist sample rate, the minimum sample rate must be taken to recover our original signal back. That is 150 hertz. So what are the options given in the problem? 100 hertz, 200 hertz, 300 hertz. Now comment. Now give your comments. A. Statement A. Sampling frequency equal to 100 hits. Can recover the original signal? Please respond. No. No? Second case?
Yes.
Yes. So option A, cannot recover. Cannot recover x of t. Okay. At this sampling rate. Because 100 hits is less than 150 hits as per the Nyquist rate. As per the Nyquist rate. So can recover. Can recover x of t. Can recover x of t from its samples if we take sampling rate more than 150 hertz. 150 or more than 150 hertz. Okay. So in this way also the questions will come. You have to do carefully. It is for sync pulse. Okay. Next problem. Determine the Nyquist sample rate. Determine the Nyquist sample rate. Determine the Nyquist sample rate and Nyquist sample interval. Nyquist sample intervals for the following. For the following. Okay. So first questions. Sin square of 200 pi t. Second question. 0.5 sin square of 200 pi t. And third question. Sin 200 pi t plus 3 sin square of 120 pi t. Combination of these two. And the last one is product. Sin of 100 pi t multiplied with sin of 100 pi t multiplied with sin of 200 pi t. Okay. So for this signal, we have to find out Nyquist sample rate. That is Fs. And then 1 by Fs. Ts. Nyquist sample intervals. Okay. Solution for this problem. Solution. Before starting the problem, we will recollect some basic information about the sync pulse. Suppose a triangular pulse is there. We found the Fourier transform of triangular pulse, Fourier transform of rectangular pulse in unit 3. So this is a triangular pulse. If we find the CTFT for this triangular pulse, the result is your sync pulse. Okay. This is tau by 2 x of j omega. Tau by 2. The entire signal is tau by 2 sinc square of omega tau by 4. Omega tau by 4. Okay. CTFT of this triangular pulse tau by 2 sinc square of omega tau by 4. Right. Next, if we apply the duality theorem, that is x of t equal to tau by 2 sinc square of t tau by 4. Now the Fourier transform result is x of j omega, this is 2 pi, is 0, tau by 2 minus tau by 2. Okay, please remember some sinc square of some function t tau by 4, Fourier transform result is you will get triangular pulse with the magnitude of 2 pi at 0, at omega equal to 0, minus tau by t to tau by 2. So these diagrams and all are not necessary to draw in your examination, for your understanding purpose only. Triangular pulse CTFT tau by 2 sinc square of omega tau by 4. So if we take tau by 2 sinc square of t tau by 4 Fourier transform as per the duality theorem, then you will get this signal. This is one set. Likewise, rectangular pulse. Suppose if we take CTFT of a rectangular pulse, 0 tau by 2 minus tau by 2 magnitude 1. CTFT. The result is x of j omega equal to tau sinc pulse of omega tau by 2. If you sketch like this, okay, x of t rectangular pulse, result is tau sinc of omega tau by 2. Apply the duality principle. T tau sinc of t tau by 2. Okay. Now your result becomes a rectangular pulse. Omega x of j omega equal to just 2 pi. Magnitude 2 pi from minus tau by 2 to plus tau by 2. Okay. So please remember these two concepts. CTFT of a rectangular pulse. Tau sinc of omega tau by 2. Tau sinc of t tau by 2. The omega are replaced by t as per duality theorem. Then this one is multiplied with 2 pi. Magnitude multiplied with 2 pi. 2 pi into 1, 2 pi. Minus tau by 2 to tau by 2. Triangular pulse, triangular signal, Fourier transform tau by 2 sinc square of omega tau by 4. As per duality theorem, change this omega by t. Then whatever this result multiplied with, magnitude multiplied by 2 pi. So 2 pi, say minus tau by 2 to tau by 2. So these all are basic concept. Okay. To solve this problem, please remember this pattern. Sinc square Fourier transform, what is the result? Okay. Sinc t tau by 2, what is the result? Right. So now first problem. First option, x of t equal to sinc square of 200 pi t. Sync square of 200 pi t. Okay. Sync pulse square. See here. Sync square of t tau by 4. The value in the bracket, the value is t tau by 4. So you have to compare your value 200 pi t equal to t. T tau by 4 equal to 200 pi t. Okay. So we have to get tau by 2 only. We have to get tau by 2 only. Tau by 2 equal to 400 pi. So here the tau by 2 equal to your omega m. Tau by 2 is equal to your omega m. So whenever the sync pulse is given, sync of t tau by 2. This tau by 2 is your omega t. Sync of omega t. Okay. So sync square of something. Then t tau by 4 equal to this value. From this tau by 2 is your actual omega m. So 2 pi fm 400 pi will be cancelled. Fm equal to 200. Therefore, Fs should be greater than or 2 times of 200 greater than or 400 hertz. So for the first problem, the sampling frequency must be greater than or equal to 400 hertz. Okay. So if sync pulse is given, check whether sync or sync square. If it is sync, meaning whatever the content is given, that is tau by 2. So that you can directly consider as your omega m. Okay. If sync square, this entire term equivalent to t tau by 4. So you have to find out tau by 2. Tau by 2 is the actual omega m. Next, Ts, the sampling time interval. Ts equal to 1 by 400 second. Ts equal to 1 by 400 second. So you will get 2.5 millisecond. You get 2.5 millisecond. Okay. This is the first problem. Second problem given, x of t equal to, first one sync pulse 200 pi t plus 3, this is for third one, okay, plus 3 sync square of 120 pi t. Now how to solve this problem? Sync 200 pi t, sync square 120 pi t. If more than one signal given, what we need to do? Find the frequency content of this one. Find the frequency content of this one. Which one is highest? That you have to consider as Fm. Okay. So from the first section, tau by 2. This is tau by 2. Tau by 2 equal to 200 pi. Okay. Here square is it. Tau by 4 equal to 120 pi. So actual omega m is in sync pulse is tau by 2 only. 240 pi. Okay. So omega m1 equal to 200 pi. Omega m2 equal to 240 pi. Find 2 pi fm1 equal to 200 pi. Okay. 2 pi fm2 equal to 240 pi. So pi will be cancelled. fm1 equal to 100 hertz. Okay. fm2 120 hertz. fm2 120 hertz. So which is highest frequency now? Two separate signal is there with different frequency. So sync pulse of something equivalent to tau by 2t. Okay, sync square of tau by 4. So anyway, you convert into tau by 2 equal to what? And here tau by 2 equal to what? That is your omega m value. 100 hertz FM1, 120 hertz FM2. So now what is the final FM? What is
120.
120? Nyquist rate. Nyquist rate says Fs must be greater than or equal to 2 times of maximum frequency content of the signal. This Fm represents maximum frequency content in this signal. So 100, 120. Therefore, Fs must be greater than or equal to 2 times of 120. Okay, 2 times of 120. So 240 hertz. 240 hertz. Or Ts. Or Ts equal to 1 divided by 240. So we'll get 4.167 millisecond. Okay. So this is for problem 3. If more than one sync pulse, in that case also one sync pulse and one sync square data. Then how to solve? Second option, I think, what is the second problem? 0.5 sync square of 200 pi t. Okay. So already first problem sync square related problems only. First one, sync square of 200 pi t. Here, sync square of 200 pi t. Only magnitude is different. Don't worry about magnitude. In frequency domain, what we analyzed, the frequency content is the important. We are not worrying about the magnitude content. So therefore, same as problem number 1. Okay. For second problem, whatever the first problem answer, same. Sync square of 200 pi t. Same problem we solve. Sync square of 200 pi t. Okay. So there is no more changes. Now the last one is very important. Last one is very important because if it is sin A sin B, we can expand easily. Sync of 100 pi t multiplied with sync of 200 pi t. Sin A sin B you can expand easily, but it is sync pulse. So how to solve this? This is for x of t. This is for x of t. But sampling theorem we used in frequency domain. So if we find x of j omega, okay, x of j omega, x1 of j omega convolution with x2 of j omega. If signals in multiplication in time domain, then result in convolution in frequency domain. Okay. So x1 of j omega. Let's consider this is x1 of t and the second part is x2 of t. Okay. Sync of some function. What is the Fourier transform? That is the introduction class. Sync of some function. If you take Fourier transform, you will get rectangular pulse. You will get rectangular pulse like this. Tau by 2 to tau by 2. So your x1 of j omega, your x1 of j omega zero 100 pi minus 100 pi. Okay. Your x2 of j omega, your x2 of j omega plus 200 pi minus 200 pi. Okay. Now we have to perform convolution between these two, x1 of j omega, x2 of j omega, like unit 2. Okay, convolution between these two rectangular pulses. That is our x of j omega. That is our x of j omega. Graphically, we have to perform the convolution. x1 of tau, x2 of x1 of k, x2 of minus tau using this formula. Graphical method, summation x of tau h of t minus tau. Not summation. It is a continuous time signal. Y of t equal to x of tau h of t minus tau into d tau from minus infinity. Okay. So if we perform convolution between these two, please remember two rectangular pulses. Okay. Convolution between these two, your x of j omega become a triangular signal, 0, 300 pi minus 300 pi. Okay. Otherwise, you just remember this one rectangular pulse minus 100 to 100. This is another rectangular pulse minus 200 to 200 pi. If you perform convolution in continuous time domain, you will get a rectangular pulse from minus 300 pi to 300 pi. Okay. This signal we need for finding our Nyquist sample rate, particularly for this problem, because the signal multiplied with this signal. Previous problem, signal 1 plus signal 2 plus signal 3, no problem at all. Find individual frequency component and check which one is highest value. From that, we can easily find sampling frequency or Nyquist sample rate. But if the signal is multiplication of 2 or 3, then individual CTFT of individual signal and perform convolution between these spectrum and you will get this. Okay. So extreme case, you will get this kind of problem. Please remember, if two sync pulse comes in the form of product, then how to solve this problem. Now in this example, omega m equal to 300 pi. So Fm equal to 150 hertz. Okay, because 2 pi Fm equal to 300 pi. So pi will be cancelled. Fm equal to 150. Therefore, Fs Nyquist sample rate. Therefore, Nyquist rate Fs 2 times of 150, that is 300 hertz. That is 300 hertz. Ts equal to 1 by Fs. 1 by 300 hertz. 3.33 millisecond. 3.33 milliseconds. Okay. So that's all about problems in sampling theorem. That's all about problems in sampling theorem. In all aspects we covered. Okay. Sync pulse square or product of sync pulse. Please check your question paper carefully, whether it is sine or cos function or sync function. Okay. Previous problems are very simple, because cos 10 pi t, here sine square theta 1 minus cos 2 theta by 2, sine function, cos function, no problem at all. Okay. So whenever the problems comes in the form of sync pulse, then check the problem carefully, whether it is sync of some function, some value, or sync square of some value. If it is sync square of some value, then tau 4 by 2 or t tau by 4. You have to equal t tau by 4. These values will be equal to t tau by 4. Then find tau by 2. Okay, then find tau by 2. Tau sync of t tau by 2. This is a format of sync pulse. Okay, then CTFT result minus tau by t to tau by 2. Magnitude we are not going to worry about. We need only the frequency component. Simple problems only, but to take care while looking at the question paper. So any doubt in today's class?